Ladies and gentlemen, once again, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Gu. Today we're doing notes number 4, and it's all about transformations once again. But today the focus is on reflections. Oh boy. So, believe it or not, the general form of all absolute value functions is f of x equals a times the absolute value of b times x minus h, close absolute value sign, plus k. This looks very confusing, but when you see the actual equation, it's a lot easier. And actually, all of our functions kind of follow this general form. So some key points about the absolute value function, though, is that the vertex is at h comma k. That is where the vertex is. Remember, the vertex is a point. And the axis of symmetry is the line x equals h. So, quick little quiz question. Will the vertex be the maximum or minimum on the parent function of an absolute value function? It will be a minimum. That's right, a minimum. Because remember, the parent function for absolute value looks like this. It's a v. And the vertex is this sharp corner point. Is that a maximum or a minimum? It's the lowest, which means it's a minimum. Oh my goodness, yes. All right, so now look down here. Consider the function f of x equals the absolute value of x minus 4, close absolute value, minus 3. What are the transformations? Well, first I see that right here we've got the minus 4 on the inside of our operation, inside of our function, which means that's going to move our graph right to the right 4 spaces. So right 4 units. And then we see the tagged on at the end here, the minus 3. When you tag things on, that's up and down. That's a vertical translation. And so this is going to be down 3 units. All right, good. Now, where's the vertex? Looking at our equation, we can tell where the vertex is because look up here. Our vertex is at hk. H is inside our absolute value, and k is on the outside. So that means my h, in this case, is right here. It's the 4. And my k is out here. It's the negative 3. So my vertex is going to be at 4, comma, negative 3. Now that is because our inside is minus h. We can see the minus 4, so it's just 4. And the outside is plus k, but we see a minus sign here, so it's going to be minus 3. All right, now where is the axis of symmetry? You can see on the notes up here, the axis of symmetry is the line x equals h. We already said that h is going to be 4. So that means my axis of symmetry is going to be x equals 4. And there it is. Wow. So looking at our general form of the absolute value function equation, then we can find the vertex and the axis of symmetry. All right, so remember, yesterday we looked at vertical and horizontal translations. H and K, remember H and K, those two letters change our function vertically and horizontally. Now, let's explore what the A and the B in the general equation would do to our graphs. So check this out. The first one, reflection. When the function is multiplied by negative 1, so that the function takes the form f of x equals negative absolute value of x. It could be anything, but we're using negative absolute value just for example. The graph will be reflected across the x-axis. The x-axis is right here, right? So if it's reflecting across the x, it's going from here, up here, down to over here. This would be reflecting across the x-axis. See, across, boom, the x-axis. So let's look at some examples then. This one says absolute value. In black, we're going to graph the parent function. Now, we've already done this a bunch, so we should remember the points. Negative 2, 2, 1, 1. So it's just a v like this. So we've graphed the parent function right there. And so there's my parent function, f of x equals the absolute value of x. Now in red, we're going to graph the function g of x, which is going to equal negative absolute value of x. So let's actually just plug in some values and see what we get. Okay, so let's go with x and the y. Let's do -3, -2, -1, 0, 1, 2, and 3, just to have a bunch of points. So look, it equals negative absolute value of x. So if I plug in -3, watch this, g of -3 equals negative absolute value of -3. What is the absolute value of -3? That's just +3, but we need to bring down the negative sign. So my final answer is going to be -3. So same thing with g of -2. So g of -2, let me write it up here. G of -2 is going to be negative absolute value of -2. Well, absolute value of -2 is just 2, but we need to bring down the negative sign. So that just attaches to my +2, and we have -2. So let's go through these. F of -1 would be -1. F of 0 would be 0. F of 1 would be -1. F of 2 would be -2. And F of 3 would be -3. So if we plot these points, we'll see we've got -3, -3, -2, -2, -1, -1, 0, 0, 1, -1, 2, -2, 3, -3. And so our new graph should look like this. So what transformation happened? We had a reflection, reflected across x-axis, because we have the negative sign out in front of the absolute value. So let's look at the next one. In blue, graph the function h of x equals negative absolute value of x minus 3. Now, we can use the information that we knew yesterday to just know what happens. So first we've got the negative in front of the absolute value of x. We already did that one with the red. So we're going to reflect across the x-axis. And then now from yesterday, we know that if I tag on a -3 at the end, what does that do to my function? That moves my graph down 3 spaces. So all I have to do is look at my red graph, my g of x, and just move down 3 spaces from what I see. So 1, 2, 3 right here, 1, 2, 3 right there, 1, 2, 3 right there. And so without actually doing all the equations over again, I can just count down 3 spaces from everything. And there we have it. We reflected across the x-axis, and then we translated down 3 units. All right, so I want you guys to try to do this next one, the square root example. So in black, we're going to graph the parent function. Remember, that's 0, 0, 1, 1, 4, 2, and 9, 3. That's my parent function for square root functions. In red, we're going to graph the function g of x equals negative square root of x. We should be able to tell by the negative sign out in front that we're just going to reflect across the x-axis. So I'm going to go ahead and write that. Reflect across x-axis. So all I have to do is look at my points and then just mirror image them. This one's 1 space above the x-axis. I'm going to go 1 space down. This point, next point is 2 spaces above the x-axis. I'm going to go 2 spaces down. And this point way over here, 9, 3, is going to become 9, negative 3. And I have reflected across the x-axis. All right, now look at the blue. Let's see what we're going to do with this one. We've got the negative sign outside, so of course we're going to reflect across the x-axis. But then what do we see on the inside? We see a +3. What does +3 do to our graph again? That moves it to the left 3 spots. So shift or translate left 3 units. So I can just look at my red, my g of x, and then move to the left 3 units from that. 1, 2, 3. 1, 2, 3. 1, 2, 3 right here, and then 1, 2, 3 right here. So when I graph this, it's going to look something like this. And that is reflection across the x-axis and shifting to the left 3 units. All right, let's flip it over to the back side now. This is another reflection. So take a look at this. When the variable is multiplied by -1, so that the function takes the form f of x equals absolute value of negative x. We can see this time the negative sign is inside our function, inside our operation. The graph is going to be reflected across the y-axis. So if I had like a triangle right here, I'd reflect it across the y-axis. That means over here, boom, because the y-axis is the straight up and down one. And then my triangle would look like this. See, that's the reflection across the y-axis. And that's when the negative sign is on the inside of your operation. So let's take a look using the square root example. Let's do the parent function. We got 0, 0, 1, 1, 4, 2, and 9, 3. And then in red, we're going to graph the function g of x equals square root of negative x. What transformation happened? So in this case, we can only use negative numbers, because if I put a positive number in for x, I'm going to have a negative number, and you cannot take the square root of a negative number. So watch this. X, y, we're going to do it mathematically here. So x, let's do -9, -4, -1, and 0. So watch this. When I plug in -9, g of -9 equals the square root of -9. What's a -9? That's just +9. So this is actually the square root of +9, which is 3. So what happens when I put g of -4? I get square root of -4, which is the square root of 4, which is just going to be 2. What if I put the g of -1? I'm going to get 1, and if I put g of 0, I'm going to get 0. So we can see these are our new points. -9, +3, -4, 2, -1, 1, and 0, 0. So we can see that this new graph is a reflection over the y-axis. We can see that it's a reflection over the y-axis from our original parent function. So that's what the transformation is. Reflected over y-axis. And that's because our negative sign was on the inside of our function. Okay, so let's do the blue one then. In blue, we're going to graph the function h of x equals square root of -x and then -4 at the end. So we can see the square root of -x, the same transformation is going to happen, reflected over y-axis. So my red right here, this red graph already shows the reflected over y-axis, but this has an additional -4 at the end, which means we're going to shift down 4 units, or translate down 4 units. So I'm looking at the red function, I'm going to go down 4 units from there. 1, 2, 3, 4, right there's a point. 1, 2, 3, 4, there's another point. 1, 2, 3, 4, there's another point. And then 1, 2, 3, 4, there's my final point. And we can see that our new function right here is a reflection over the y-axis and then down 4 spaces, down 4 units. So I want you guys to try now with quadratics. Okay, so the parent function of quadratics, remember, is -3, 9, -2, 4, -1, 1, 0, 0, and then 1, 1, 2, 4, and 3, 9. This is my parent function. Boom. That's this. Now in red, we're going to graph g of x equals, parentheses, -x squared. But if I'm reflecting, you can see the negative signs on the inside, right? That means I'm reflecting over the y-axis. But if I reflect this graph over the y-axis, it's literally gonna land right on itself. So if I reflect it over the y-axis, look, boom, it just lands on itself because it's already a mirror image of itself. Okay, that's interesting, but let's look at the next one, blue. So for the red, I'm gonna write reflected over y-axis. You can't actually see it, but it did happen. And now for the blue, graph the function h of x equals negative x squared plus 1. The negative here is on the outside of the x squared, which means that this is going to be a reflection. Well, I almost spelled it wrong. Reflected over x-axis, because the negative sign is on the outside over there. And then what does the plus 1 tell us? It tells us that we're shifting up 1 unit. Shift 1 unit up. So if I reflect over the x-axis and then shift 1 unit up, I'm going to do this. Watch this. First, if I reflect over the x-axis, I'm going to be here, 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 and here. But now I need to shift 1 unit up, so I'm actually going to erase all these and just move them up 1 unit. So right here, right here, right here, here and here, and then lastly right there, right there. And this would be my h of x. Reflection over the x-axis and shifted 1 unit up. All right, and on to the last one. I want you to try this, the absolute value. So graph the parent function. We should know this one by now since we've done it so much. It's just going to be the v. And now we're going to graph the red. Now let's just use what we know. So we can see that as g of x equals absolute value of negative x, we can see the negative sign is on the inside of the function, which means that the transformation will be reflection over which axis? When it's on the inside, the negative sign is on the inside, reflection over the y-axis. But if I reflect this v over the y-axis, we can see that it's already a mirror image of itself. So once again, once I reflect, oh gosh, what a ripoff. If I reflect it over the y-axis, it's just going to land on itself because it's already a mirror image of itself. So let me just draw over this. All right, now let's look at the blue though. The blue is going to be negative absolute value of x plus 3. The negative sign is on the outside, which tells us to reflection over, when it's on the outside, which axis does it reflect over? The x-axis, over the x-axis. Okay, and then the plus 3 tells us that we're going to shift where? 3 units up. So watch this. I'm going to do it in pencil first, and then I'm going to erase that and go into the pen. So reflection over the x-axis would first just look like this. Right? This is the reflection over the x-axis. But that's not it. It also tells me to shift 3 units up. So then from here, I'm just going to move it 3 units up. So I'm going to take some of the points from my absolute value function. We know negative 2, so I'm going to go up 3 units from here. So 1, 2, 3. So that's one of the points. 1, 2, 3. That's another point. 1, 2, 3 right here. Right there. Right there. There, right there. So my new graph is actually going to look like this. And there we have it. So make sure you remember where the negative sign is and which axis that flips it over. So real quick, let's fill out this bottom part. What do each of the letters do to the parent function? Now remember, we can look at the original form to help us see where every letter goes. H is going to be a horizontal shift. So if H is a horizontal shift, what is K? K is the vertical shift. All right, what about for A? A is on the outside of our function. When A is negative, I'm just going to put this, then that's a reflection over the x-axis. And then finally we see the B, that's on the inside of our function, inside of our operation. And when B is negative, then we reflect, so it's a reflection over the y-axis. And there we have it. That concludes our notes all about reflections. So see ya in the next one. Peace!